Alright, section 1.5 is broken up into 5 different parts. And what we're going to be doing is analyzing graphs of functions, which is going to involve a bunch of little small things. Okay, so what we're going to worry about in this first video is being able to determine the domain, being able to determine the domain and the zeros from a graph. And I don't have it written down there, but we're also going to be working with the range of a graph. Skip, 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 skip. Alright, domain and zeros. Determining the domain from a graph is simple. There's just one thing to keep in mind. Okay? If a graph, if a graph has endpoints, you need to pay attention to whether or not the points are hollow or filled, because a hollow point means that it does not include the endpoint. You also hear it referred to as being not inclusive, and that would be equivalent to greater thans and less thans without the equals. Okay, that's what the not inclusive means. If it's a filled circle, that means that it does include the endpoint, and it's referred to as being inclusive. So if you hear the expression between 5 and 10 inclusive, that means it includes the 5 and the 10. If you hear the expression between 5 and 10 not inclusive, it means it's everything between 5 and 10, but not actually 5 and not actually 10. Okay, so we're also going to work with a new way to write the domain, different notation, and the range, and that's by using brackets. You'll hear me refer to soft brackets and hard brackets. Soft brackets are not inclusive. They do not include those endpoints. A hard bracket, on the other hand, is inclusive. It includes the endpoints. So here's a graph, in case you couldn't tell what that was. And it has a domain, if you look, that goes up to but not including 3. And it starts up again at 5. Okay, so if you think about which values are represented here on the number line, everything this way, all the way up until 3. Then it skips up to 5 and includes everything in this direction again. Okay, so the way that we write the domain is between negative infinity to 3, and then from 5 to infinity. Okay, so it's everything out that way, which, by the way, is the direction of negative infinity, up until 3, not inclusive. That's why I have a soft bracket there. And then it starts up again at 5, and it is inclusive, which is why I have a hard bracket there, all the way up to infinity. Now, one other point to make, an infinite bound is always a soft bracket, okay, because it's not precise. We have no idea where this, well, actually it doesn't end, so you can't say that it ends at a certain point. Alright, let's try another one. Alright, now this graph goes from -4 to 6, and it is inclusive. So there is your domain. Next graph. What do you think? It starts way off at negative infinity, and it goes and goes and goes and goes, and there are no restrictions on this thing at all. Okay, so the domain is negative infinity to positive infinity, and don't forget that it's a soft bracket. The range is a set of all the y values that are the result of the function. Okay, and the notation is done exactly the same as the domain. So let's take a look at this problem right here. That's a fancy looking graph. Okay, the domain. Now understand that when we look at these, we want to start at the left and move our way to the right. Okay, it shows it stopping right there, but is it actually stopping right there? It's not. This graph continues to go on. So it's actually going from negative infinity in that direction, and blah, 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 it goes to positive infinity in that direction. So my domain is negative infinity to positive infinity. The range, on the other hand, well, we can, and when you do the range, you should start at the bottom and move your way up to the top. And I didn't want you to see that yet. Start at the bottom, work your way to the top. Okay, there's nothing down here. It's all not used until you get to this point right here, which is -3. And then everything in that direction is used. So the range is -3 to infinity. And the -3 is inclusive in that. It doesn't skip that point, it includes it. Let's try another one. Actually, let's not. Let's talk about zeros, since that's the last thing we want to talk about on this particular video. In section 1.3 we talked about the x and y intercepts. When we talk about the zeros of a function, we're only asking for the x-intercepts, or where f of x equals 0. Okay? So we're interested in only where it crosses the x-axis, not the y-axis, specifically when they ask us just for the zeros. Okay, now in section 1.3 we learned how to find the x and y intercepts. So if you want to brush up on that, you can go back to that video. Because all we're doing for zeros is setting y equal to 0 and solving the equation. And that should be no problem. So that's it for this video. Goodbye.